Welcome out to Upper Lake Mary. That's Upper Lake Mary right behind me here. That's the dam at the head of it up there. Lower Lake Mary is up towards Flagstaff. So if you don't know where this is about 15 minutes south of the city along South Lake Mary Road. And we get these two bodies of water sitting down here. This is part of our drinking water supply. And we're here for a little geologic puzzle. So what I want you to look at here, at the first of three spots we're going to stop at, is the rock that I'm sitting on and that we're looking at. So this is loose next to me here, you can see, but it's bedrock. It's just kind of been dug up. This is what it looks like underneath us. So we're going to take a look at it, try to figure out what it is, and then we're going to see what kind of rock we have at the other locations, and then we're going to see what in the heck is going on here. So, from what you can see, here's a piece of it, all right? We've got brownish color and grayish color to almost black, all right? If we look real close, I don't see any particles of sand or anything like that, but I do see some little shiny bits sitting here. So if you're thinking gray, black, brownish, no particles of sand, but something shiny. Think back to the things that we've looked at. What kind of rock do you think this is? Make a guess in your head before I tell you. This is basalt. Okay, this is igneous basalt that we've looked at. So it formed from a magma that crystallized very quickly because it is a lava flow. So this that we're standing on, sitting on, looking at is a lava flow. It's about 6 million years old, okay, which is in geologic terms what we call pretty new, young, but for everyone else, like, it's pretty cool. I'm holding a 6 million year old thing in my hand. That's pretty awesome. So what we have down here at the lake in the kind of valley here is basalt, okay? Now what we're gonna do next is head across this way to the ridge line that pops up there, up to Anderson Mesa on the other side. So we're gonna go up to the top of this thing, and then we're gonna come back and look sort of at the slope itself, and we're gonna see what exactly it is that's going on out here. Here's stop two. So what we've done is we've driven up from the valley, up this little switchback road up here, and we've come up to basically the top of this ridgeline up to what is called Anderson Mesa up here. So this road goes up to Marshall Lake, if you know this area. And actually right behind me here is a low observatory station with several telescopes, including this crazy huge thing that's the highest resolution optical telescope in the world. Pretty cool. So these are the rocks we've come up here to look at. This is what the bedrock is made up of up on top of Anderson Mesa here. So I pick up a piece and try to get you in a little bit. These are, color-wise, we're seeing gray, brown, black. Okay, if I look carefully, I don't see any little sand grains or things like that. I do see little shiny things. So take a second and guess what it is I'm pointing at this time. And don't take too long because it's not a trick question. This is the same rock. This is actually the same rock we were just on down at the bottom of the valley. So that's interesting. That means this is, in fact, the same lava flow, the same 6 million year old lava flow that we had down there. Now, lava flows are roughly horizontal layers, right? Pours out and it flows. And we're seeing this up here is a roughly horizontal lava flow. Down in the bottom of the valley is a roughly horizontal lava flow. I haven't really given you a puzzle yet, have I? But what we're gonna do is we're gonna make our last stop halfway down the side of the ridge here on this road. We're gonna see what's in between the bottom and the top. All right, let's go. All right, here we are halfway down the slope, looking at the rock that makes up the side of the slope. Let's get a good look at it. And finally, one of these things is not like the others, is it? So here we're looking at something that's pretty different. Here we're seeing different colors. We've got light tans, more brown. Cars that go by, they're not part of it. There will be another one in a second. We're seeing horizontal layers in here, right? Hello. So if we zoom in a little bit and get a closer look, you'll be able to do this if you go down on the page on Canvas. I have a gigapen from about this spot where you can zoom way in and look, but we're seeing all kinds of layered stuff in here, right? So we should be thinking about something different. And for another hot clue, let me actually get you in even closer. Hang on. So if we take a close look right into this spot, we get way in there. You may be able to see something. So first of all, I've got kind of a chalky sort of appearance here. Can you see that? I rub my finger across it. It's rough, feels a little gritty. And if we look really closely, we may see some little shapes, little kind of half crescents. That little bit there has lines on it. And these aren't super great or super easy to see. A microscope would be better, but these are fossils. These are little fossil shells. There's more of those fossils right here, by the way. So what is this thing we're looking at then? If we have shell fossils in it, if we're seeing gritty texture, if we're seeing horizontal layers, then we are looking at a sedimentary rock. Okay, and this is, if you guessed sandstone, that would be an okay thing to think based on the way it looks because of this particular one, but this is actually a limestone. So this is limestone. It's 270 million years old, and this tells you that 270 million years ago, where we are right now was the bottom of an ocean. So we would be under the sea. We would be looking at these little seafloor critters, and that's what these fossils are. Okay, so that's pretty cool. Now, where does that put us? So if we have a lava flow down in the valley behind you, a lava flow up at the top of the mesa here, but the side of the slope of the ridgeline is made up of limestone. How can we do that? And this is what I want you to think about. So think about how we could get a horizontal, we'll say, layer of lava at the top of this thing, a layer of lava at the bottom of this thing, but this steep slope between the top and the bottom is a limestone, a totally different kind of rock. And I really want you to pause it and think about this for a minute. Try to come up with a couple of possibilities, and then we'll sort of work through them, okay? So, what could this be? Could be, you say, there was a lava flow from the top of this thing that just poured down over the side and went down into the valley. Good thought. However, we don't find any lava in between the top and the bottom. Okay? So, think about figures you've seen in class where you have one thing up here and then a steep slope, and then that same thing shows up again at the bottom. Okay? Color it in if you need to. Think about what this could be because it is a fault. This is a fault. That lava flow up there and that lava flow down there were the same lava flow, and then a fault broke them and moved them. So this is the Lake Mary Fault. There's about 300 feet of change from the lava flow on the top to the lava flow on the bottom over time, and this has been moving for millions of years. I mean, obviously less than 6 million years because that lava flow is that old and had to break after it formed. But it's been moving for quite a long time. So this whole ridgeline you see when you drive down South Lake Mary Road is a big fault. And it's not just sort of a giant feature. I'm sitting on the fault. So this kind of rough whitish stuff that you see here is actually kind of soft. It's called fault gouge. It's what happens when blocks of rock grind against each other and grind up stuff in the middle, right? And it kind of jams together, and that's this stuff. And this vein of calcite right here that you might be able to see is fluid flowing through that crack of the fault and depositing minerals as it goes. So like this is it. This is my finger on the fault. And the whole face of this ridgeline is the fault. So it's exactly like what we see in our textbook illustrations, but real big. And you've been driving past it maybe if you live around here. So it's a fault, and it's an active fault. So there are earthquakes on this fault, and this is in fact probably the most worrying fault that's around in terms of risk for Flagstaff. So this thing runs from around Mormon Lake to the south all the way up to Flagstaff and under the city, okay, for some extent. That whole length of it doesn't all look exactly like this, but it's part of the fault. If the whole thing, the whole section of the fault were to slip all at once, we'd be looking at about a magnitude 7 earthquake. That's big. That's really big. If in a more likely kind of scenario we have one section of it, so like maybe from here down to Mormon Lake or here up to Walnut Canyon, if only that portion were to move during an earthquake, then we'd be down closer to a 6, so maybe a magnitude 6.3 is a more realistic kind of thing, which, as we'll learn in a little bit, is significantly less dangerous than a magnitude 7. If we had a magnitude 7 in Flagstaff, that's something like $1 billion disaster, all right? And we would expect to see hundreds of injuries, lots and lots of damage to buildings, especially buildings that aren't designed too well for earthquakes. And that is all part of this. So this thing hasn't had a big earthquake in kind of recent history. About 10 years ago, there was a cluster of little baby magnitude 1 to magnitude 3 earthquakes just a little south of here, but I don't think anyone really noticed that. Those were too small. But the potential is there, and based on the fact that this fault is here, you know it moves, and you know that because we see little activity around, it is still active, and someday we'll get a big one. Maybe right now. Okay, no, we're still safe. The other part of this is that if you've driven from Flagstaff down to Sedona, along the highway there, down through Oak Creek Canyon, Oak Creek Canyon is another fault exactly like this. And actually, if we were to turn around and look that way, you'd see the other side. It's a mirror image of this. So here we have a mesa that comes down a fault, down to the valley floor. You go to the other side of the valley and up that wall, that's Oak Creek Canyon. So it's a similar fault from the other side. By the way, both of these are normal faults, right? So this is that sort of pair of normal faults that as you stretch the rock apart, you allow the section in the middle to float down the ramp, slide down the ramp, and settle in that way. So that one too has earthquakes on it. It is also active. Just a few years ago, we had a magnitude 4.7 over there, which people in town noticed. It happened during the night, but still enough shaking to notice, and we'll see that when we get to it in the investigation. So we will investigate this kind of risk from like a map view sort of perspective when we get to that investigation, but I want you to see it, right? And now you know where it is. You could come drive down and take a look at it and touch it yourself, right? So hope you enjoy the field trip, and I'll catch you back in class.